for the Sharkbite domain of number 1, and it's okay if you didn't get this, but we will be talking more about this here in a bit. Domain of number 1 was, you could write it one of two ways. X is greater than or equal to 2, or 2 with a square bracket to infinity. For number 2, which points are solutions? If you plotted all 3 of these points, any point that fell in the shaded area would be a solution, and there was this one, negative 2, 4. 0, 3 fell on the dashed line, so that would not have been one. And then number 3, we needed to combine like terms. So after you distributed, there were a bunch of x's and a bunch of constants, and when you combine them all, you got x minus 20. Questions on those 3? For the back, number 4 is asking, is this graph a function? If you draw a vertical line anywhere through that, it would not touch more than one place. So yes, it is. Then number 5 is asking for the equation of this line. So we would need to find the slope and then find the y-intercept. To find the slope by doing y2 minus y1 over x2 minus x1, our slope would become negative 2. Then we could use one of the points to put in and solve for y. I chose 2, 0. Using the equation of the line how we write the formula. And when we do that, the equation became y equals negative 2x plus 4. Questions on either of those? Before we start our notes for today, I want you to look at your course calendar. There are some important dates on there. You'll see that really this would take about 6 to 8 classes, but there's a bunch of breaks in there. So we're going to start this lesson and be working on it today, tomorrow, Friday, or this unit. And then next week is going to be benchmark work, benchmarks. So then we're going to take a break from the unit. And then the week after that, come back to it. But then the week after that is spring break. So there's a lot of breaks in there. So be mindful of that. Be mindful of those dates. I think I need to update Canvas because I don't think all of the dates are there. Yeah, I think that's it. Do we have any questions on the calendar? So today we're going to start the first part of this lesson. Everyone should have notes that look like this. Some of this will be review from things we've done in the past. So like here we're going to be talking about domain and range and different notation. And we have touched on that and talked about that before. Like with quadratics, we talked about domain and range. We talked about interval notation when we did inequalities. So a lot of this will feel familiar, but just in case it's not, we're going to review it. So a couple things we do need to remember is that if we have less than or equal to or greater than or equal to symbols, these are going to give us square brackets, and vice versa. If we have less than or greater than, strictly less than, strictly greater than symbols. These are going to give us parentheses. And if we need to go to positive or negative infinity, we're always going to be using parentheses. So going through some of these are written in set builder notation, and our goal is to write them in interval notation. So using the brackets and parentheses. X is greater than -3. We would start at -3, and if it's everything greater than, it's going to keep going to the right towards positive infinity. So this would be -3 with parentheses, and it would go to positive infinity. Bless you. X is less than 8. Would stop at 8, so it's going to keep going below 8, everything to the left. So it's going to start at negative infinity and go to 8 and stop there, but it's not included, so that would be a parenthesis. For x is less than or equal to 2, it's very similar to that last one. It's going to keep going to the left. So it's going to start at negative infinity. It's going to stop at 2. But because this is included, it's equal to, it's going to have a bracket. For the next one, x is greater than or equal to 0. Would start at 0. And because it's equal to, we'll have a bracket. It will keep going to the right towards positive infinity, and then we'll have a parenthesis. So all of the other ones in this section will be written one of these 4 ways. We just have to figure out which way. So for x is less than 4, what are we starting with? So we're going to end at 4, but it's going to keep going to the left. So we're going to start at negative infinity. And if we're ending at 4, would that be parenthesis or bracket? Parenthesis. X is greater than or equal to -5. Where would that start? -5. Would that be parenthesis or bracket? And that would go to positive infinity. X is less than 1/2. Where would that start? Negative infinity. And go to 1/2. Parenthesis or bracket? X is less than or equal to 5. Where would that start? Negative infinity. It would stop at 5. Parenthesis or bracket? Bracket. X is less than 12. Would also start at negative infinity. Stop at 12. Parenthesis or bracket? X is greater than -1. Where would that start? Start at -1. Parenthesis or bracket? And go to infinity. X is less than 1.5. We start at negative infinity, go to 1.5, parenthesis or bracket. X is greater than or equal to 4. Where would that start? 4. Parenthesis or bracket? Bracket. And that would go to positive infinity. X is greater than 17. Where would that start? Parenthesis or bracket? And we'll go to infinity. x is less than or equal to negative 3/8. Negative infinity. Go to negative 3/8, parenthesis or bracket. And x is greater than 6. Where would that start? Parenthesis or bracket. And go to positive infinity. Now we're going to do the opposite. Now we're going to be given interval notation, and we have to write it as set builder notation. So if it's like one of these, something to infinity or negative infinity to something, it'll be is greater than, is less than, greater than or equal to, less than or equal to. When it has two numbers, that's written a little differently. So when it has two numbers like this, the parenthesis bracket rules still apply, but it's starting at -6 and it's ending at 4. So this would be -6 is less than x, which is less than 4. I'm starting at -6, but -6 is not included, and I'm going to 4, but 4 is not included. And your notation or your domain or whatever this is would be all of the values in between there, not including -6 and 4. Yes. Well, it depends on what it's asking. So if it was like range, it'd be a y. But for the most part, for these, we're just going to put x. Negative infinity to 5. Would that be less than or greater than 5? Less than. And it'll be strictly less than since this is parentheses. So x is less than 5. -2 to 2 would be written very similar, except one would be equal to and one would not. So -2 is less than or equal to x, which is less than 2. The next one would be also written similarly, but this one would both have equal to's. So -3 is less than or equal to x, which is less than or equal to 3. So in that case, it'd be from -3 to 3, including the endpoints. 8 to infinity, would that be greater than or less than? Greater than. And this has a square bracket, so that would be greater than or equal to. We've seen this next one, negative infinity to infinity, before. But this would be all real numbers if it keeps going negative and positive. And it would be written like this. X, this weird E with this weird R, which means X is an element of, or X is a part of, all of the real numbers. So all the negatives, the positives, the fractions or decimals. The rational numbers, all of those. Another way you could write this is just the R. Either or. From 0 to 5, how would we write that? 0 less than or equal to less than 5. 3 to 12, how would we write that? -7 to infinity, is that greater than or is that less than? In this case, it would be greater than. Even though we're starting with a negative number, it keeps going to infinity. It's equal to, so they'd be greater than or equal to negative 7. 3 to 5, how would we write that? Three is less than x is less than or equal to 5. Yes. As soon as we finish these 5 years. 1 to 2, how would we write that? So really this is saying it's bigger than 1, but it's smaller than the other. It's in between these values. 3 to 4, how would we write that? Five to 6, how would we write that? Less than 6. 7 to 8. And 9 to 10. What did you write that last one? So knowing how to write these will help you when we go on to writing domain range, increasing, decreasing, things like that. Turn over to the back. So as we're doing this, I may refer as these words. I may use starting and stopping. I may interchange those. This group is supposed to be floor. So when it says these things, it's talking about, so your ceiling would be your highest point that your graph does not go past. Your floor would be your lowest point that your graph does not go past. The walls would be the furthest point left and right that it does not go past. So if you have any of those, I would draw those in. You can label them, you don't need to. So like for this first one, I can say this has a floor. It has arrows coming up. That means it's going to keep going up forever and ever. So it can't have a ceiling because it doesn't have a limit to stop at. I also can't draw in walls or starting and stopping points because if this keeps going up and out, and this keeps going up and out, the walls are ever expanding. So this order says do the range first. That's really because the range uses your y values where everything else really doesn't. So if you want to focus on that first, you can, but the order here doesn't really matter. So if I'm looking at my range, I'm just looking at my y values. The floor and the ceiling helps me determine that. Where does my range start? What is the lowest point?
-2.
-2. Because the bottom of this function is not a whole, we can say it's included. So this would start at -2. This would be a bracket. And where would this stop?
No.
It doesn't. It keeps going to infinity. So our range would be from -2 to infinity. Now for our domain, we're looking at our x values. Domain, I personally feel, is a little harder because you have to imagine what it's doing. You don't just see it. So you have arrows and you have to imagine that this is going up and out. So if this keeps going up and out to the left, this is going to keep going left. And if this is going up and out to the right, this is going to keep going to the right. So if it's going out to the left and to the right, what would your domain be? Negative infinity to positive infinity. And you'll see that a lot of these domains are going to be like that. Now, the other part, the increasing, decreasing constant, it may help you if you, on your x-axis, draw a line with an arrow going to the right. That's going to tell you that we're looking at our x values as they're moving to the right. When we're looking at increasing, decreasing, and constant, we're looking at our y values and comparing them to our x values as we're going to the right. So what I mean by that is, what are my y values doing as my x's keep increasing? This helps me because I'm a visual person. On my function, as my x's keep moving to the right, I'm going to draw arrows along the function to see what my y values are doing. So from left to right, my y values start going down. And then they go up. So for increasing, that would be anywhere where your x values are increasing as well as your y values. Decreasing would be where your x values are increasing but your y values are not. Constant would be where your x values are increasing but your y values are staying the same. So for increasing, where does this start? Looking at your x values, where does this start increasing?
3.
At 3. If it helps you, or if you want to draw in a line at 3, that way you know that's my starting point. It's going to increase from 3, and when does it stop increasing? So it has arrows. If it didn't have arrows, then yes, it would stop at 2. But in this case, because of the arrow, it's going to stop or not really at infinity. Now we can look at the other part of this, the decreasing. Where does this start decreasing? Negative infinity. And where does it stop decreasing?
3.
So this would keep decreasing until it gets to this point at 3. These things are usually connected. Wherever you start and stop, you usually start at that same place and then continue. There's nowhere on here where this is constant. Here. Yes.
Wait, so you mean on the x-axis?
Yeah, so we're just putting x values, but we're comparing our x and y values on this. I'm going to re-explain that here in a second. So whatever we put here has to be x values, but when we do this, we're comparing what is happening to our y values and x values at the same time. So in this case, there weren't any, because your y value would need to stay the same. It would be a horizontal line. Or which part? So for increasing, we see that this starts at this line and then starts to go up. Your y values start to go up. And you're looking at your x values. So at 3, it starts to increase. For decreasing, it's decreasing all the way at negative infinity until it gets to this point. Then it changes direction. What other questions do we have on this? We're going to stop there for today and we're going to finish these tomorrow.